everyone, this is Steve McCauley with a quick video to show you some of the new additions coming up to the MyOwnRadar display on WFAA.com. So let's go ahead and get right to it. Of course, when you go there, you'll see the standard radar display show up when you log on. Well, not log on, but when you access the website on WFAA.com/MyOwnRadar. And again, this is just some data that I took a few days ago during the big thunderstorm event. We had all the tornadoes moving across parts of North Texas. This is when things were kind of settling down, so I apologize. It's not quite as exciting as what I could show you, but I didn't really think about making this video until toward the end of that thunderstorm event. But anyway, this is what the radar looks like. You're probably pretty much familiar with this. And again, you have a lot of options up here across the top portion of the screen, and I'd like to kind of go over these individually. And some of these you probably really already know. For example, lightning. If you click on the lightning, you'll see where the lightning is occurring. Now, this is only lightning that actually strikes the ground. I've kind of removed the lightning that flashes from cloud to cloud. So where you're seeing the little plus signs there, that of course is where the lightning is actually making contact with the ground itself. Now I'm going to click these on and off, because if you start clicking them all on, it gets really kind of cluttered. So let's click on the storm motion. And again, this is the 1 hour storm track. This is the computer attempts to find the core of the thunderstorm and plot its direction of motion and where that core is going to be within an hour time. Now I'm going to go ahead and I'm going to stop this and take it to the very last frame of the animation. This is the most recent image. And again, you can see how the display is showing you the storms are moving in a northeasterly direction. It doesn't really tell you how fast they're moving, but here's a really kind of a quick and dirty way of finding out just how fast they're moving. Click on the distance button up here, and then click down on the storm core, and then drag your mouse to the length of that line. And since that line is showing you where it's going to be in an hour, and if that line is 31 miles long, as you can see here, well, obviously that storm is moving at 31 miles per hour. Okay, that's really not the reason why I put in the distance measuring device in there, but that's one thing that you can use it for. For example, here's another storm to the northwest of Corsicana. And again, this one's moving a little bit faster, about 37, 38 miles per hour, because that is the length of that line that projects the storm an hour into the future. Go ahead and push this again down to the go, and you can see it moving right along. Now you'll notice that whenever you activate one of these buttons up here, you can remove it or put it back on, depending on exactly what you want to do. Now what do the colors mean? Well, again, this is where you can pass your cursor over the colors of the radar data and show you and interpret for you what the radar is actually revealing. Again, I'm going to kind of stop it on the last frame so this doesn't get too complicated. But you can see as you put your mouse over the colors of the radar, it shows you just how hard the rain is falling. Again, this is a radar estimate. It's not 100% accurate, but it's about the best that we can do. And it does give you a pretty good idea of the intensity of the precipitation moving your way. Let me go ahead and click off storm motion here. Oh, there's a nice little core there. See, that's over 4 inches an hour there. Probably a little bit of hail in that as well. And we'll get to the hail representation here in a minute, but you can see that is a very, very heavy rain core right there. Let me go ahead and take that off. And let's see, what about the hail? Okay, let's click on the hail. And again, when you see these little hail balls inscribed over the radar data, it's trying to estimate the size of the hailstones. Now, again, when I took this, things were really settling down. We didn't have a lot of hail being displayed here. This is all less than 1 inch in diameter. Whenever you don't see a number inscribed inside the little hail ball, that means it's less than quarter size. Once it gets up to quarter size, you'll see the number 1 inscribed here. Once it gets up to $half size, you'll see 1.25. Ping pong ball size, that's 1.5 inches. Golf ball is 1.75. Size of eggs is 2. Tennis balls 2.5. Baseballs 2.75. Again, all of these numbers will be inscribed inside these little hail balls to give you an idea just how big the hail is. Okay, it goes up to 6 inches in diameter. I don't think there's ever been a hailstone 6 inches in diameter. We've had one pretty close. No, I take that back. We have had them a little over 6 inches. Not down here in North Texas, So if we ever do start seeing that kind of size hail, I will be adding that to the algorithm. But for right now, I've capped it off to a 1/2 foot in diameter, and then that's bad enough. All right. So that's your hail. Here's a new feature that I'm putting on. I'm real excited about. I call it hail tracks. It gives you the footprints of the hailstorms that have moved across the area. Now this is the hail tracks from 6:27 p.m. May 28th to 8:26 p.m. May 29th. So all of these colors here indicate where the hail has occurred within this time frame. And again, you can come up here and click on what do the colors mean and pass your cursor over to see how big the hail was in that particular area. Again, this is kind of a neat little thing that I put together. It's a modification of the algorithms used by the National Weather Service. It uses hail sizes that are actually reported, plus the hail sizes that are being estimated by the radar, and it compares the two and tries to adjust to make sure you get the best estimate possible. Okay. For example, here's a little bright color up here. And I'm going to zoom in. Now you can zoom in either by clicking inside the radar window, or you can do what I'm about to do, and that's use my my middle mouse button. Okay. And you can zoom in, and now you can really see, ooh, yeah, there we go. Let's see, ooh, a little over 2 inches in diameter up there to the southeast of Bonham, being estimated by the radar. Okay, so some pretty good radar indications there. And again, when you start zooming down using the navigation bar up here, you can zoom down to the Metroplex, the 4-county Metroplex, or you can zoom down to Tarrant and Dallas counties, or Collin and Denton counties, or wherever. Then you can really get high resolution and kind of see what neighborhood the hailstorm hit. This might be really good for hail adjusters or people who do roof repairs. You can actually see where most of the damage may have taken place. Okay, so again, that's my hail tracks. I'm kind of excited about that. Let's put the radar back on. Click on rotation. You're probably familiar with this. This is where there's actual significant rotation being detected by the radar. Again, I'm going to stop it here. And inside the little swirls, and you can see the swirls indicate just how fast it is rotating. It's on a scale from 1 to 10. Let me remove that color interpreter here. It's on a scale from 1 to 10. So this is weak rotation. 2 is twice as strong, and it goes up to 10. When it gets up to 10, that's something to really get concerned about. Although I do want to say this, a 1 circulation this far away from the radar, again, your radar is down here south of Fort Worth, which you can see that here. It's in the Crowley, Burleson area. If you've got a rotation center that far away and it's showing up as a 1, that could possibly be a 2 or a 3 if it were closer to the radar. Because remember, the farther away you are from the radar, the more blurry the radar sees. It's not quite as high resolution. So this is seeing a 1 circulation. How far away is that from the radar? Looks like it's over 100 miles from the radar. So, but it's still detecting it. So that's probably a significant rotation, even though you might think, it's not so bad. It's only a 1. Look up here, a 2 being indicated from the radar, and it's over 100 miles away as well. So again, it's all relative speaking. These 1s and 2s this far away from the radar might actually be 3s and 4s once you get down here. And typically, once you get up to a category 3 rotation, that's something you really want to watch. A lot of your storms are going to have category 1s and 2s. Okay, that doesn't mean there's anything major going on, but if they persist and if they strengthen as you animate the radar, then that's something you're going to want to watch, because that's often an indication that the core of the storm is getting stronger and stronger, and it bears watching. I might want to mention that the tornado that hit Canton had a maximum, I believe, of a 5. Okay, and that was a pretty nasty tornado. So again, you don't have to have a 10 to have a tornado. Although I should say this as well, even if you have a 10, that doesn't necessarily mean you got a tornado as well. This is just an indication of wind shear, where winds are changing speed and direction over a short distance. And that obviously is what a tornado is all about. But it doesn't take a tornado to make the winds change speed and direction over a short distance. Straight line winds can do that as well. So you have to take this with a grain of salt. It's not perfect. Okay, radar is not a perfect instrument, but it is the best that we have, and it's usually pretty good. Now, I do have something that I call intense rotation. Obviously, at the time that this was taken, there was nothing being indicated as being intense rotation. We didn't have any tornadoes on the ground at this time. There were no tornado warnings at this time. But intense rotation means that the change in wind speed and direction is taking place over a very short distance. Okay, so we're really trying to isolate where tornadic thunderstorms are occurring. And again, if you're more than 50, 70 miles away from the radar, it is very rare to see intense rotation show up on the radar. Simply because, again, the radar is not as high resolution once you get that far away. And plus, you're looking at the curvature of the Earth. The Earth is round. And therefore, as the radar beam goes out over the Earth is curving out from underneath it. So the radar beam is getting higher and higher and higher off the ground the farther away you are from the radar, and you're going to miss a tornado on the ground if you're too far away from the radar. You may still see circulation up there in the clouds, but again, you're not going to see circulation at the ground simply because the Earth is round. Sorry, flat earthers, the Earth is not flat, it is round. And because of that, the radar beam actually goes above the Earth's surface quite a distance, several thousand feet above the Earth's surface once you get over 100 miles away from the radar itself. Okay, so you rarely are going to see intense rotation, even if there is indeed a tornado on the ground when it's far away from the radar. Now, if you see intense rotation within 50, 60, 70 miles of the radar, and again, just to kind of give you an idea where that would be, okay, within this radius here, again, does not guarantee a tornado, but I would certainly be watching that very carefully, especially if it persists. If radar scan after radar scan after radar scan shows you intense rotation and it stays there, then that's probably something damaging going on. Okay, not always. Again, it's not a perfect instrument, but that would be something I would be really concerned about. Okay, I'll click that off and go to bulletins. This you're familiar with. This is your standard. All watches and warnings can be seen by clicking on the bulletins. If you pass your cursor, you don't even have to click. This is a flash flood watch that we were having. Of course, the red is a tornado watch. This bright green is a flash flood warning. There's some other colors in here embedded in the flash flood watch. There's a river flood warning. And again, if you want to get the details on all of this, just go ahead and click on it. And what you'll get is all the details of that particular warning. Okay, you can make this window any size that you want, but just click on it and you'll get all the details of that specific warning. Again, let's click on the flash flood watch, and there you can see issued by the National Weather Service here in Fort Worth, and there's all the details telling you how long it's going to last and what they're expecting and things like that. Okay, so that's your bulletins. Now, compared to warnings. Now, what's a warning? Warnings are only flash flood warnings, severe thunderstorm warnings, and tornado warnings. Okay, that's all you'll see when you click on warnings. Bulletins is everything. Okay, but if you don't want to see everything, just click on the warnings, and then you'll see. I may have to do something with that color. That doesn't show up very well, does it? Okay, I can make them any color I want to. But anyway, there you go. Those would be your warnings. And they change over time as the storms move across the screen. Okay. Now, this LSR is a local storm report. This is where storms have been reported and something unique about them. For example, up here we had 3/4 inch hail the size of pennies or dimes. I don't remember which one of that is. Anyway, it's less than a quarter, because if it was a quarter, you'd have 1.00 there, right? Here we have some wind damage, and again, all I'm doing is I'm just passing my cursor over these. I'm not clicking on them or anything yet. Up here we have some hail reports, 2.75. That's some baseball size hail there, just to the southeast of Paris. Now you'll notice there's actually two reports here, and they're on top of each other. So what you'll want to do when you see that is kind of zoom in, and they'll separate. Okay, And if you want to get some details, just click on them and you'll see that this was baseball size hail near Blossom, reported by the emergency manager there. This is going to be 2-inch diameter hail. This is your basic hen eggs from Reno and so on. Looks like we had some wind damage here. House damaged along Highway 34 south of Honey Grove. Okay, of course there's a little Honey Grove there. And now you get down here to the tornado reports that we had here. If I click on here, you'll see we had a brief tornado touchdown 2 miles to the northwest of Fate there in Rockwall County. And of course here are the Canton storms. This was the first tornado that was seen. It was a multi-vortex tornado with debris in the air near Highway 47, 4 miles to the west-southwest of Canton itself. And then there's the Canton tornado moving into town. Okay, so again, if you zoom in, you'll separate these out so that you can get a better idea of what they're trying to tell you. And again, that's the LSR, the local storm report. Okay, let's see here. Some of the ones that you're probably already familiar with, the precipitation type. Now, of course, when you click on it now, it's going to paint everything green because everything this time of the year is rain. But as you get into wintertime, this precip type will change the colors of the radar imagery to reflect either rain, freezing rain, sleet, and snow. Okay, and again, MyOwnRadar differentiates between freezing rain, which is an ice storm, and sleet, which is the little pellets of ice that hit the ground and they bounce. Not quite as bad as an actual ice storm. That's freezing rain and sleet are not the same thing. And MyOwnRadar will try to pull the different precipitation types out. A lot of displays, and I don't really want to denigrate anybody else's display, but a lot of displays will just lump everything together and call it a wintry mix. Well, some wintry mixes are worse than others, okay? And so MyOwnRadar will pull out the ice storm from a sleet storm. Okay, you can probably drive on sleet. You can't drive on freezing rain, basically, okay? But again, probably won't get to use that again until the winter season. Now, here's a new update. This is one I've been working on a long time. Now, we've already had this, the estimated rainfall, and again, you can do the same thing. You can hit the what do the colors mean and pass your cursor over the colors, and it tells you how much rain the radar here in Fort Worth is estimating with these various storms. Now, I'm going to skip this 1 hour QC rain here and go over to the total QC rain momentarily, because the estimated rain and the total QC rain is essentially the same product with a slight difference. I notice I had a misspelling there. I'm going to have to change. But anyway, total QC rain is the estimated rainfall, but it's quality controlled with actual rain gauges. In other words, estimated rain is what the radar thinks fell. QC rain is what the radar thinks fell, but also it incorporates what actual rain gauges are telling you. So when you click on estimated rain, you can see some really high rainfall amounts up here in the bottom area. But when you click on the quality controlled, that area of excess rain is much, much smaller because apparently the rain gauges were not reporting those extreme events. So this actually backs off a little bit from the estimated rainfall tally and tries to make it correlate to what's really happening in the real world. Okay, you'll also notice that the total QC rain here is more expansive. I mean, it covers bigger territory than just estimated rainfall, because estimated rainfall only comes from the radar out of Fort Worth, and it has an effective range of about 124 nautical miles. To get farther away, you have to incorporate other radars from the Dyess Air Force Base near Abilene, from Oklahoma City, from Frederick, Oklahoma, from the radar down south of Waco. When you do that, you get a more complete picture and a more accurate representation. In other words, you get second and third, fourth opinions of what the rain is really doing. So again, this is kind of exciting. Again, you can see how it overestimated, and here is the quality control. Now, is this perfect? Is this exactly what happened? No, it is not. It's still an estimate from the radar's sites, but it is augmented by actual rain gauges that are out there. So this would probably tend to be more accurate. For example, let me zoom in here. I can actually show you this with an example from my house. For whatever reason, my house, which is located right near the center of this green blob, is a good way of showing just how accurate this was. Now, notice the radar in Fort Worth did not estimate as much rainfall. How much did it estimate? About 1.31 inches. What did the quality control estimate? It estimated about 1.49. Well, I can tell you for a fact that that cursor is right on my house, and we got 1.55 inches of rain. So this quality controlled, although not perfect, at least not with my particular rain gauge in my backyard, is a lot closer to what the estimated rainfall from the radar site itself, okay, from Fort Worth. So again, kind of exciting that we have that backup, that it actually compares to what the rain gauges are showing. So now we can come over here to the 1 hour QC rain. This is how much rain has fallen in the last hour. And this is kind of cool to use for flash flooding, because look over here, you've got rainfall rates approaching 2 inches an hour, ending at 8:22 p.m. on May 29th. Okay, here's another heavy rain core down here southeast of Corsicana, and of course much less, as we were behind all the action by this time here in the Metroplex. Okay, but again, this kind of gives you an idea how much rain is falling within an hour period, whereas the total gives you the total amount of rainfall since the whole event started. Okay, so again, I like that. That's kind of a cool deal. And then just kind of rounding out the discussion, you've got your temps, you got your feels like temperatures. This is either going to be the heat index or the wind chill factor, depending on the time of the year. Weather observations, this is the full observations. And again, I'm going to just zoom down here. And you can see that I've kind of simplified the way that the weather observations are given. Here in the upper left-hand corner is 82 degrees Fahrenheit. The dew point is 71. That puts the relative humidity at 69%, and that makes it feel like 88 degrees. So that's how you interpret these numbers here. The winds here are out of the south at 12, gusting up to 19 miles per hour. Over here, they're out of the southeast at 9 miles per hour with a temperature of 80 degrees, and so on and so on. And again, you can see how the wind arrows are out of the south and southeast here, but they're out of the north and northwest here. Yeah, there's your cold front coming through, right? And right here, the winds are smashing into one another, which is why we had showers and thunderstorms. Again, whenever the winds come together at the surface, that means the air has to be going straight up. And if you don't have a cap, and you have plenty of moisture, that air that's going straight up can turn into showers and storms. So again, you can see how the cold front's coming down with the winds turning around to the north, smashing into the winds coming out of the south here, creating that line of showers and thunderstorms that we saw just a few days ago. Now, it gets really kind of cool whenever this is like a blue norther, because the arrows will turn colors depending on what the temperatures are. And when you have temperatures like in the 80s down here and the 30s up here, you just see all kinds of blues smashing into yellows, oranges, and reds. And it's really kind of pretty. But it's a dramatic display showing you when a blue norther comes blasting on through. Okay? So again, that's your weather observations. All right? And then finally, you have your actual forecast. I'm just going to turn the radar. You don't have to do this. I'm just going to turn the radar off. Once you got it into forecast mode, now you have to be careful when you click, because now it's expecting a click to mean that's where I want to know what the weather is going to do. So for example, if I were to zoom, you don't have to, but I'm going to zoom into McKinney and I'm going to click on McKinney. Okay. What's going to happen is you're going to get a forecast, and this is going to be hard to show you because I'm kind of off screen, but what it shows you the weather forecast for McKinney. I can actually move this around. I apologize. I'm not able to move this so that you can actually. Oh, maybe I am. Yeah. See, when you click on that, it gives you the forecast for McKinney. Okay. Oh, I've never done this before, but there you go. Okay. You can see how it gives you the forecast for McKinney from the National Weather Service. All right. It gives you the current conditions as well. Obviously, I'm doing this right now, so you're getting a totally different number than what we saw on the archive radar data. All right. So, but there you go, and you get the next 5 days or next 7 days for you whenever you click anywhere within the button. Let's go back over here, and there you go. Okay, and just you want to make sure you click that off, because no matter what you do, whenever you click on it with this activated, you're going to get the forecast and it may not zoom in like you want to. For example, let me go ahead and click on the Metro view. This is going to give you a little bit higher resolution data as you zoom in. Again, let's put the radar data on there. And again, as I move in, now you actually get to see the city limits. Okay, here's my little combine. Okay, there's Crandall and so on. So again, it gives you a higher resolution as you click on the various locations within North Texas. Now, a lot of radar displays will give you the entire country, and you can zoom down to city street level. Well, I don't do that with MyOwnRadar, and there's a couple of different reasons. One, in order to do that, basically you have to use fake radar. There's no radar that can give you the entire radar picture across the country. That you have to stitch together 150 radars to get all of that. So when you start zooming down using a mosaic of 150 stitched radar sites together, what you end up with is a general picture of what the radar imagery looks like, but it's not accurate. It's not very accurate, and it's not real. You'll see ovals, you'll see storms that look like ovals within ovals because you're overlaying all these radars on top of each other, and it makes for a fake radar display, and I'm not going to do that. Okay, I'm not going to let you zoom down to your backyard showing you fake radar data, which may or may not be anywhere near accurate. I mean, radar data was never meant to zoom down to your backyard. Okay, and so I will let you zoom down as far as the radar data resolution permits, which is down to maybe your city, maybe a certain side of the city. But no, I'm not going to let you look at the entire United States and then zoom down to 2102 Maple Street in Plano. That's not going to happen on MyOwnRadar because it's not real. All right. Again, there's other vendors out there that will let you do that, and that's fine. All right. But I'm only going to show you what is real as far as what the radar data was intended to use. Okay, so that's why I don't do those type of displays. And I like the idea that you can zoom in with MyOwnRadar and instantly the radar data is there, and instantly the background is there, and instantly the cities and the streets and the roads are all there. You don't have to wait for it to tile in. You don't have to wait for the radar to come in the little blocks, those little artificial blocks that come in. Again, I know I sound like I'm on a rant here, but again, the reason why you do that is that if you want to have one radar display that fits everything, one size fits all is one of the reasons why you would do that. I make the radar display for MyOwnRadar for every portion of the country individually. It takes a lot of effort and a lot of time to do that. But I think in order to get reality, to get the highest resolution data, to get the most accurate data, you have to do that. Okay? MyOwnRadar is not a one-size-fits-all type display. Okay? You're not going to be able to track storms in South Florida from North Texas instantaneously. You have to go to a display that I've created for South Florida to do that. And I've created displays all across the country. Okay, I've got clients all across the country. Okay, but I don't do it in a one-size-fits-all type environment. Okay, so that's why you don't have that. That's why you can't, with this particular display, go up to the Texas Panhandle. I've got displays made for the Texas Panhandle, but you can't get there from here. I apologize, but that's just the way it is. Okay, that's the way that MyOwnRadar is set up to work. Okay, that's enough of that. All right, and some of these other ones, if you want the radar display to go faster, you just click on faster. If you want it to go slower, obviously go slower. Here's a little thing that's going to become important a little bit later on. You can click on the latitude, longitude, and move around and find out what the latitude and longitude is. That's not really all that important for the viewer, but Coming up soon is going to be some other interesting things for my own radar, and it's very important that I know the latitude and longitude, so that's why I have that there. All right, if you want to capture the image of the radar, you can. If you're tracking storms and you've got lightning on and you've got rotation on and things are all crazy and you want to go back to what it was, just hit the restore button and it takes you back to the default display. That saves you from unclicking all of these other things. Okay, so that will just save you a little bit of time. Oh, I didn't go over Storm Tracker, did I? Let's do Storm Tracker one more time. Let's say that you wanted to track a storm. Let's say this one down here. Okay, well, you click on the storm tracker and you click on the storm you want to track. And then you click where it is in the future. And now you can see that this storm is moving east-northeast at 38 miles per hour. And you can see how it will be in different locations at different times based upon its movement over the last 10 or 15 minutes or so. Let me do that one more time. Okay, you click on Storm Tracker. All right. I wish there were some storms over on the left-hand side because my Storm Tracker is going to go off screen. But anyway, so I'm going to click on Storm Tracker, and what that does is it takes you to the very first radar image. Okay, so let's say I want to track this storm that's northwest of Athens. So I click on that. All right, and then I click on where it is now. And it's moving east at 26 miles per hour, and at 9:52 p.m. it's going to be just to the southeast of Tyler. Okay, again, I'm going to do something. If you want to click on another storm, just go up here and click on that. Let's say that there was a storm here in Comanche, and then it was over here, and now you can see all the different times that the storm is expected to be, given that it's moving to the northeast at 57 miles per hour. Okay. So again, I really like the storm tracker. It doesn't give you the towns in the path and what time the towns are going to be hit because that's copyrighted and it's not my copyright. So this is the next best thing that I can do and not violate any copyright infringement there. All right, so I'm going to click that off. So there you go. That is my own radar. I'm going to be upgrading WFA's website pretty soon with this, and there's something really, really cool coming up in the not too distant future. I can't really tell you about it right now because I haven't beta tested it all the way yet, but you're really going to like it, I think. All right. So that concludes this 32-minute video of my own radar. I hope you enjoyed it. If you have any questions, don't hesitate to ask, and I will get to as many as I possibly can and try to answer your questions. So thanks for watching and have a great day.